Good morning, everyone. How are you all doing? Good. Anyone have anything fun they did over the weekend? Like that's like worth unmuting and saying. Yeah, same here. So I went and checked. It looks like you guys all did this. At least from my end, I'm seeing that you all did the syllabus verification. So great job. Got some labs turned in, got some mastering chemistry going on. I know that there are still some people that have gotten a little bit delayed with like getting their lab manuals and things like that. So you can still turn your labs in. They will just be counted for, I'll get slightly less credit. I won't be quite as strict for this first round of labs. So if you haven't done any of that stuff yet, get it done, sometime this week. Then moving forward, you just turn it in when it's due. Oh, the first lab is due on the 24th. Okay, yes, the first lab is due on the 24th. Yeah, one of my other sections, I think my 092 section had a lab due. Maybe not my own. It doesn't matter to you guys. You don't have anything till the 24th. Yeah. You did have one of your mastering chemistry assignments though due. So hopefully you're able to get in there, figure it out. Mastering chemistry, I know, can be a little bit sometimes and cumbersome, especially if you don't have like a really great computer for the interface. But that is the tool that we have. So do the best you can. Okay, so let us get back into chapter 2. We were talking about we were talking about prefixes, the beauty of the metric system. And how we can, increase, let's go back here. We can increase or decrease by adding a prefix. So 1 meter is the same thing as 100, and then we put a little C in front of it, or centimeters. Or you could flip this and say 1 centimeter is equal to 100th of a meter, right? Those two things say the same thing. So we like prefixes. They work for us. Here's some more. Again, doesn't matter what the base is, the prefix still has the same magnitude. So a kilo, whether it's a kilogram or a kilometer or a kiloliter, it's always going to be 1,000 of the base units. So conversion factors and writing conversion factors. In the United States, the contents of a lot of our food is listed in US and metric. So for instance, if you're looking at this can, it has a net weight of 5 ounces or 142 grams. So this would be the US or the British system. This would be the metric system. Those two things are both true. It's saying this can is equivalent to 5 ounces and this can is also 142 grams. So we could actually say that those two values are equal to each other, right? That would be a conversion factor. We're relating one unit to another unit. So sometimes they're called equalities. We have two different units to describe the same amount of something. They're written for relationships between units of the metric system, like within the metric system, between the US and the metric, and between US units. Here are some examples. So 1 meter is equal to 1,000 millimeters. Both of those things are talking about the same length. We've just shifted the unit. Why would you do that? Because sometimes it's easier to use one unit than another unit, or maybe you're talking to, if we were to, let's say we were using this one down here, 2.2 pounds is equal to 1 kilogram. Let's say we were trying to describe the weight of a car to somebody who lives in Germany. They're going to maybe have a little bit of a harder time conceptualizing 2.2 pounds than they would kilograms. So we would try and convert it for them. So all these things are saying the same amount. 1 pound is equal to 16 ounces. I'm sure if you guys have done like any sort of baking or things like that, you've used conversion factors, right? There are so many tablespoons in a quarter cup and things like that. So within every conversion factor or equality, there are a few different ways that you can write these things. One way is to write it like this. So if we're looking at 60 minutes is equal to 1 hour, we can write it like this, 60 minutes equals 1 hour, or we can turn it into a fraction, which is really useful when we do this thing called dimensional analysis, which sounds really scary, but it's just a way to set up converting things in a very neat and orderly way. So in this case, we could have the numerator, which is the number on top, be either the 60 minutes or the 1 hour, either way. If this is 60 minutes though on top, then the denominator will have 1 hour on the bottom, or it's saying for every 60 minutes, it's equivalent to 1 hour and vice versa. Now remember, these two things are talking about the same value. Even though they have different units, they're talking about the same value. So what is anything divided by itself? It's just a value of 1, right? So you can kind of think of this equality as a factor of 1. So whenever we use equalities and equations, we're not actually changing the quantity of it, we're just changing the unit value. Why would you use, this one versus this one, or this one versus this one? It's dependent on what you're going to and from. If I was going from minutes to hours, I'd use this guy over here. If I was going from hours to minutes, I'd use this one over here. And I'll show you guys later how to do that, how to set that up. Here's another one for a metric equality. 1 meter is equal to 100 centimeters. Again, we can write it either with 100 centimeters on top and the meter on the bottom, or the meter on the top and 100 centimeters on the bottom. Depends on which direction we're trying to convert. So how many equalities are there? So many equalities. There's so many. How many do you have to have memorized? Well, since we're doing an online format, you don't actually have to have them memorized, but you do need to have them like accessible. So the textbook does have a page of conversion factors. Your lab manual as well has a page of conversion factors. So have them handy. Know that sometimes online, when we type in how many so-and-sos are in so-and-so, those aren't always correct. The internet is not always correct about things. So make sure you're getting your information from a good source. Okay. So the numbers in any equality between 2 metric units or between 2 US units are obtained by definition, and we assume that they're exact. So if I say, hey, let me annotate this for a sec. 1 meter is equal to 100 centimeters. That is exact. It's exact. Meaning there are no like limiting significant figures. So this thing doesn't have 1 sig fig, and this doesn't have 1 or 3 sig figs. It has an infinite number of significant figures. So when we're running calculations, remember we say when you multiply and divide, you go with the lowest number of sig figs. Your conversion factor will not limit how many significant figures you have. You go with the given piece of information. And I'll show you guys when we run through actual calculations. An equality between metric and US units contain measured values. So there are sig figs. I'm not, in general, like 99% of the time, 99.99% of the time, your conversion factor is not really going to limit your calculations. Even like this relationship here, 1 inch is equal to 2.54 centimeters. That's a definition, that's exact. So for the sake of this class, don't let the conversion factor limit your sig figs. Go with the given information. And that should get you through. All right, so here's a bunch of different conversion factors that, they find useful. Here's things for length in metric. Here's things for length in US. This is where we start to see why the British system is so crappy. These numbers 1 to 12, 1 to 3, 1 to 5,280 make no sense. These 1 to 1,000, 1 to 1,000, 1 to 10, right? We're only seeing ones and zeros, very neat. Here are units for volume. We've got mass and we've got time. Okay, so this could be a helpful little table to have, table 2.7. Know that if your text is a little bit later, I think the 13th edition, the tables might be slightly off. Just go to the chapter, you'll find it somewhere in chapter 2. Okay, so here's some ways to write different conversion factors. This way, which isn't super useful for dimensional analysis, and then these 2 ways, we like these. These are much more useful. So I want you to write conversion factors for each of these equalities. And I want you to write it as something equal to something. And then I also want you to write it as two fractions. So both options that you have. And if you're like, how many meters and inches are there? I'm like literally pulling out my cell phone right now because I don't know the exact relationship for that. So you can look through the text or the syllabus, or you can use the interwebs. Just be careful where you're getting your information. All right, so this first one here, liters to milliliters. Actually, I'm gonna write this on over here. Okay, so meters to millimeters. So for every 1 meter, that should equal 1,000 millimeters. Now, what happens sometimes is this number here can get flipped and people will say, oh, 1,000 meters is equal to 1 millimeter. They're like, see, look, all the numbers are right and everything. Well, they're not put in the right place. I'll tell you right now, 1,000 meters does not equal 1 millimeter. Millimeter is very, very tiny. This is a very large amount. So we don't, we want to make sure that we're pairing the number with the right unit. Now, one thing you could do is you could say that 1,000th or 0.001 meter is equivalent to 1 millimeter. Okay, so a tiny millimeter is equal to 1,000th of a meter. These two things are saying the same thing. All we've done is divided this side by 1,000 and divided this side by 1,000. I personally don't like these, and you won't see me using that a whole lot because I don't like to use decimals if I don't have to. I like the whole numbers. So that is an option, but I'm gonna stick with this first one. So we've got 1 meter is equal to 1,000 millimeters. We can write it as 1 meter over 1,000 millimeters, or 1,000 millimeters over 1 meter. Depending on which one we use, that's really based off of how we convert. The next one was I don't remember. Meters to inches. Okay, so how many inches do we have in a meter? Meters to inches. So this is metric and this is British. 1 meter is equivalent or equal. Sometimes you'll see me use colon, sometimes you'll see me use equal is equivalent to 39.37 inches. Okay, we can, sorry, this pen is giving me a hard time. We can write this as 1 meter over 39.37 inches, or we can write it as 39.37 inches all over 1 meter. It's up to you. What if you're like, oh, I did not know that relationship, but I do remember that 1 inch is equal to 2.54 centimeters, right? That's kind of a pretty well-known conversion. Well, you could have converted from meters to centimeters and then centimeters to inches. You could have done like a two-stepper. So you could have gone meters and converted it into centimeters and then centimeters into inches. Here, using the relationship of 1 meter is equivalent to 100 centimeters. And here, going 2.54 centimeters is equal to 1 inch. So when we're doing these conversions, going from one unit to another, there are multiple pathways. This is not, I don't have this one memorized, but I do know these relationships. So I probably, if I had a problem where I needed to use this, would break it down into 2 steps. It's up to you. What was our last one there? Meters and kilometers. Okay, so a kilo is 1,000. So 1 kilometer should be equal to 1,000 meters. Another way we could potentially write this is 1,000th. A 1,000th of a kilometer is the same thing as 1 meter, right? Those say the same thing. I don't like the decimal, but whatever. All right, we can write this as 1 kilometer on top, or over 1,000 meters on the bottom, or 1,000 meters over 1 kilometer. So built into this relationship, a couple different ways we can write it or see it. So be comfortable with seeing those equations or equalities written in a couple different ways. Back over here. Slideshow gives us that information. Great. Sometimes conversion factors are given for just a specific problem. Sometimes it's stated within that given problem, or it's written for only that problem. So let's say we have a problem that goes, hey, there's a car and it's traveling 85 kilometers per hour. Is that true of every single car? Does every car drive at 85 kilometers an hour? No, that's just what it is for this specific problem. It's 85 kilometers in a given hour. But it's a ratio, right? It's a relationship. It's a certain distance per a certain amount of time. So we can actually use that as a conversion factor as well. Same thing for tablets or dosages of medications. 1 tablet contains 500 milligrams of vitamin C. So, you know, for every 1 tablet, it will contain 500 milligrams, or 500 milligrams per tablet, or vice versa, 1 tablet for 500 milligrams, written in a couple different ways. These are conversion factors that we can, again, use in dimensional analysis. So here is sort of a more real life problem, but Keflex, an antibiotic used for respiratory and ear infections, is available in 250 milligram capsules. If you were to write a conversion factor for that, 1 capsule is equal to 250 milligrams. We can write it this way, or we can write it this way. So, okay, conversion factors in relationship to a percentage. So let's look at the word percent. Per, right, in a given amount, per cent, 100. Like a century. Where did my annotation go? So we've got per cent, or 100. So whenever something is written as a percentage, it's saying how many in 100 of those, or 100 gram sample, 100 person sample, whatever it happens to be. There are other things outside of percentages. There's ppms, which is parts per million. There's ppbs, which is parts per billions. This would be ppc, parts per 100. So let's look at this thing here. A person might have 18% body fat by mass. So what does that mean as far as writing it as a conversion factor? Well, if 18% means that you have 18 fats for every 100 bodies, right, or body pieces. As far as the unit is concerned, you get to fill that unit in with whatever you want. It just has to be the same unit on both sides. Okay, so 18% body fat, you could say 18 kilograms of body fat in every 100 kilograms of body mass. You could also say 18 grams of body fat in every 100 grams of body mass, or let's say we just don't like grams at all. You could say 18 pounds of body fat in every 100 pounds of body mass. That's up to you on what unit you want to use. They just have to be the same on both sides. So looking here, this says, write the equality and its corresponding conversion factors for, says, and identify each number as exact or given, and it's significant figures. That I don't care quite as much, but it's, let's say salmon contains 1.9% omega-3 fatty acids. So I want you to write a conversion factor between the amount of fatty acid and the amount of salmon. Okay, so hopefully it shouldn't take too long, but 1.9%. So that means that there's 1.9, whatever your unit happens to be, in every 100, whatever your unit happened to be. So we could say grams, 1.9 grams of omega-3 fatty acids will be in every 100 grams of salmon. And we can write that either like this, or we can write it like this. We want to make sure that we're attaching the right number though. The 100 always will go with the whole. The percentage number will always go with whatever part you're talking about. So if we said, you know, hey, 80% of students got A's, we would say 80 A students over 100 total students. So the number always goes with the part. All right, write some equalities for these things here really quick. So you just have to do one of them. You don't have to write all three of them. So just tell me what is equal to what in this. And then we'll go ahead and use some of these conversion factors. Okay, so that first one, pretty similar to the stuff we've already talked about and gone over, meters to centimeters. So 1 meter is equal to 100 centimeters, a couple different ways you can write it. These are sort of a little bit newer. So jewelry that contains 18% gold. So it's not 100% gold, 18 whatever grams of gold in every 100 grams of jewelry. You could have used kilogram if you wanted to. You probably don't have a kilogram, 100 kilograms worth of jewelry on your body at any given time. So gram might be a better unit for that. Then we have 1 gallon of gas is equal to 3.40 dollars. So 1 gallon is going to be $3.40. Wow, that's pricey. Haven't seen that price in a while. So you can write it like this or like this. Sometimes they give you the unit that it specifically wants you to use. In this case, it wants you to use gallons and it wants you to use dollars. Sometimes, like in percentages, it doesn't give you the unit. You have the freedom to pick the unit you want. So these conversion factors, we can use them in problem solving to go from one unit to another unit. And we set it up in this thing called dimensional analysis, which I'll show you guys. When solving problems, you always want to state the given information and what you're trying to find or where you're headed. I think sometimes the hardest thing for people in a problem is just figuring out what they're even supposed to do. So you'll see me get in the habit of writing given information, trying to find, given, trying to find. Write a plan to convert the given unit to the needed unit. State any sort of relationships that you know, or the conversion factors that you know, and then set them up in such a way that units cancel. So I'm going to write something, I don't think it's on the slides, these slides. Given quantities, units, yeah. Yeah, they don't have it in here. So this is sort of just a skeleton structure for dimensional analysis, but it says given units, times your conversion factor, and the conversion factor, the given units will go on the bottom. And then the desired units will be on the top. And here are given units. They should cancel with each other, and then you'll be left with just your desired unit. So that's sort of how you will always set up dimensional analysis. You start with your given units, you multiply by your conversion factor. So this is your conversion. Conversion factor. You set it up in such a way that the units that you want to go away are opposite your fraction bar, right? This is on the bottom. Here, the given's on the top, because there's sort of an inferred fraction bar with a 1 underneath it here. Those will cancel, and you'll be left with just the desired units. Let's do a really, really simple one here that follows this. So how many inches are in 2 feet? Now, I know that you can do that in your head, but I want you to set it up in dimensional analysis. So start with what is given. Your given information is the thing that has the numerical value with it. So we know that we have 2 feet. What am I trying to find? I'm trying to find inches. What is my relationship between inches and feet? Well, for every 1 foot, I have 12 inches, right? Those are equivalent to each other. So now setting it up in dimensional analysis, you always start with your given information. In this case, that's 2 feet. So I'm going to write 2 feet. Then you're going to multiply it by this conversion factor. It written like this isn't super useful. So this is where I like to see 1 foot over 12 inches or 12 inches over 1 foot. Now, which one do I want to use? Well, in this case, feet is sort of on this top fraction bar, there's an inferred fraction bar here. So I'm going to put it in yellow. There's a line here. Everything's over a value of 1, right? So there's an inferred 1 there. So the conversion factor that I want to use, well, if feet's on top here, I want feet to be on the bottom. So I want to use this guy here. So I'm going to put a line for my fraction bar, the 1 foot on the bottom, and the 12 inches on top. What happens to my units of feet? They cancel, and I'll be left with just units of inches. So this thing will have now a new value of inches. Now, the last thing to do is plug it into your calculator. So you take anything that's on the top of the fraction bar, you multiply anything that's on the bottom of the fraction bar, you're going to divide. So 2 times 12 divided by a 1 here and divided by a 1 here. So it's just going to be 2 times 12 or 24 inches. Maybe thinking, wow, that's a lot of work for me to just do what I could have done in my head. Yes, but the problems will get more complicated where it's not quite as intuitive to do it in your head. How about this? Say, how many feet make up 186.2 inches? So this one is just a little bit different than the previous one in that we're going the opposite direction. So I'm going to write my given information, 186.2 inches. Oh, and you know what? I did not round to the correct number of sig figs. This is 2 feet. This is only 2 sig figs. Pardon me. Or I'm sorry, it's only 1 sig fig. So instead, I'm going to actually, to give me 2 sig figs, I'm going to cheat here and I'm going to say it's 2.0 feet. Okay, then I get to keep my 2 sig figs there. So our given is 186.2 inches. In that case, we have 4 sig figs. What are we trying to find? We're trying to find feet. My relationship is still the same between inches and feet. For every 1 foot, I'm equivalent to 12 inches, right? Or 1 foot over 12 inches, or 12 inches over 1 foot. Start with your given. And again, this is always the same. It's always this right here, given units times your conversion factor to get your desired units. So we have this 186.2 inches. We're going to multiply it by our conversion factor. Inch here is above the fraction bar, so I want to make sure inch is below the fraction bar. So I want to use the unit that has the 12 inches on the bottom and the 1 foot on the top. The inches will cancel and we'll be left with units of feet. And this one, my calculation, instead of multiplying by 12, I'm going to take my number, I'm going to divide it by 12. I don't memorize, oh, when I'm going from this unit to this unit, I multiply. When I'm going from this to this, I divide. I set it up in my dimensional analysis and I let this thing tell me what to do. So this is saying take the 186.2 and divide it by a value of 12 because this is below the fraction bar. So my new number is, I get 15.516666667. How many significant figures do I get to use though? Remember, the conversion factor doesn't limit the number of sig figs. We assume that this is an infinite number of sig figs. So I have to go with 1, 2, 3, and 4 significant figures. So I'm going to round to 5.52 feet. All right. So again, that may feel like a lot of work for something that you can kind of do in your head because you're comfortable with feet and inches, but we'll get into some problems where it's not so intuitive. back to those slides when it's talking about the steps, state the given, state what you need, write a plan to convert, give the units, given units to the needed units, state the equalities and conversion factors, and set up the problem to cancel units. When they're saying here, set up problem to cancel units, that's the dimensional analysis. That's putting the conversion factor in the right way so that the given unit cancels with the given unit. So here we've got a person weighs 164 pounds. What is the body mass in kilograms? So we want to convert between pounds and kilograms. Our given is that we have 164 pounds. Our needed is kilogram. So we need to figure out what the relationship is between those two. So 1 kilogram is equal to 2.20 pounds. You can write it this way, or you can write it this way. We start with our given piece of information, which is the 164 pounds. Excuse me, 164 pounds. They are going to use this second one here because we want the pounds to go away. The kilogram is going to be on top. That was what will be left over. This is an exact value. This is a 3 sig fig measured value. But again, you'll be fine just going with your given piece of information. This says 3 sig figs. So when we take our 164, we will multiply it by a 1 and we will divide it by a 2.20. This will end up with 74.5 kilograms. That's all converting is. It's just setting it up so that units cancel. As long as you do that and you have the correct conversion factors, you should get the answer right 100% of the time. So I want you to try this one. A rattlesnake is 2.44 meters long. How many centimeters long is the snake? Don't use King Henry died before drinking chocolate milk in this one. I want you to do a conversion factor. So use dimensional analysis. I'll show you guys both ways. I'll give you all 2 minutes to set that problem up and try and solve it. Okay, so for this one, I already forgot it, 2.44. All right, we've got a rattlesnake. That is, the given is that it's 2.44 meters. I can't even, my brain, where are you, brain? Not working today. 2.44 meters long. How many centimeters is it? So we're trying to find centimeters. So conversion factor for this thing is relating meters to centimeters. Meters to centimeters. So 1 meter has 100 centimeters. Start with your given information, 2.44 meters. And then I need to set this up in such a way that meters will cancel. So I'm going to put the meter on the bottom. Make sure you're attaching the right number with the right unit. So 1 meter is equal to 100 centimeters. You may in the beginning want to even like go through the process of like, does this make sense? Does 1 meter make sense to 100 centimeters? Yes, that makes sense, right? So that you're not flip-flopping those. Meters will cancel and you'll be left with 2.44 times 100, which is 244 centimeters. Now, within the British system, remember we do have King Henry died before, that's our base, drinking chocolate milk. If we have our given information in meters and we're trying to go to centimeters, we need to hop the decimal to the right 1, 2 spots. What was our original 2.44? We hop it over 1, 2, oh, there we go, 244 centimeters. So you get the same answer either way. This way is a little bit faster. As far as within the metric system, I don't care if you solve it using, if you're within the units of, or the prefixes of kilo to meter, if you want to use it this way to hop, go with it. Because this sometimes is like a lot of work. But obviously, if we're going between British and metric, you can't use this. So let's do a British and a metric. Man, my brain really is just fried right now. I'm not sure why. How many meters is a person who is 63.2 inches tall? I'll give you 3 minutes for that one. So how many meters is a person who is 63.2 inches tall? right, so as far as inches to meters, I mean, I literally have to look it up right now because I don't have that one, for whatever reason, I don't have that one memorized. Meters to inches. So what, 39.37. So you can do a direct one. I'm going to do it in two steps to show you guys how you can do a multi-step dimensional analysis. So you could have done it in one foul swoop, right? So we've got our given 63.2 inches. We're trying to find meters. 1 meter is equivalent to 39.37 inches. All right, we start with our given 63.2 inches times this relationship. So the 39.37 inches goes on the bottom for every 1 meter. 63.2 divided by that 39.37. All right, we get, I need 3 significant figures, 1, 2, 3. So 1.61 meters. The answer on my calculator said 1.60528, like that. The 5 will round it up. Again, I would not necessarily solve it that way because I don't know that conversion factor off the top of my head. Instead, I would go inches. And this thing that I'm drawing here is just sort of like a thought chart or a flow chart. I would go inches into centimeters and then centimeters into meters because I know this relationship like really well. So in this case, this would be a 2-stepper. And for 2-steppers, you can do one, solve for it, and then do the next one, but I just sort of chain them together. So I start with my given information, which is 63.2 inches. And I'm going to multiply it by a conversion factor that relates these two. And I know 1 inch is equal to 2.54 centimeters. Inches is here. I want to hop from inches into centimeters. So I want to get rid of my inch. So I'm going to put the 1 inch on the bottom, and I'm going to put my 2.54 centimeter on the top. Inches cancel. And now I just have units of centimeters left. So some people like to stop, solve, and then start back up again. I'm going to keep going. So the relationship between centimeters and meters is 1 meter is equivalent to 100 centimeters. So I'm going to just add another factor here. Centimeters is on the top here, so I'm going to put the 100 centimeters on the bottom here. I want to get into meter, so the 1 meter will go on the top. What happens to my units of centimeters? They cancel. So we're going to take our 63.2 and multiply it by 2.54 and then divide it by 1,000. You will end up with the same number, all right? It will give you the same answer. So 1.61 meters, again, go with the 3 sig figs here. Why would I do a 2-stepper versus a 1-stepper? Well, anytime I can do it in 1 step, I'm going to do it in 1 step, but I just don't have this conversion factor memorized off the top of my head. So sometimes I'll do it in multi-steps. So I want you to do a multi-step problem. I want you to actually solve it in multiple steps. How many seconds are in 14.6 weeks? And I'm going to help a little bit here by setting up sort of a thought chart or a flow chart. So we know something about weeks. So we're given weeks. Now, unless you've got some like really useless information jumbling around in your head, I'm sure you don't know how many seconds are in a week. So let's do this in increments. Weeks, I would go from weeks into days. That's an easy conversion. Then I go from days into hours, hours into minutes, and then minutes into seconds. Okay, so this is a 1, 2, 3, 4 hop problem. So you should have 4 conversion factors with this. So go ahead and string those together. I'll give you all, give you 3 minutes for that one. All right. All right, so in this flow chart that is super messy, I'm sorry, these are supposed to be little arrows. At each of the arrows, there's a conversion factor there. So I'll write those in different colors. So the relationship between week and days. One week is equivalent to 7 days, right? Hopefully all these conversion factors you know off the top of your head. As far as days and hours, 1 day, you get 24 hours. It doesn't always feel like you have 24 hours in a day, but there are somewhere in there. Hours to minutes, 1 hour is equivalent to 60 minutes. And then minutes to second, 1 minute is equivalent to 60 seconds. So start with our given information, which is 14.6 weeks. 14.6 weeks. And I'm going to, first thing is get myself into days. So weeks to days. So I want week to go on the bottom and I want day to go on the top because I'm getting out of weeks into days. I have to fill them in with their corresponding numbers. So 1 week produces 7 days, all right? Weeks will disappear on us. You could stop, but I'm gonna just keep chaining them together. So now I'm gonna relate days to hours. All right, so day needs to go on the bottom, hour needs to go on the top, and then I need to fill it in with their relationship. 1 day gives me 24 hours. The days will then cancel. Next one is to get from hours into minutes. So put hour on the bottom, minute on the top. What I don't want or what I want to cancel, put on the bottom. 1 hour where I want ahead, minute goes on top, 60 minutes. And then the last step is, and look, hours canceled. And then the last step is to relate minute and second. So for every 1 minute, I have 60 seconds, right? So the minutes cancel. So we can see every unit is disappearing except for the last unit, which is what we're trying to find it in, which is seconds. So we plug this in the calculator, and in this case, all of our numerical values are on the top. There is nothing on the bottom. It's all ones on the bottom. So we don't need to actually divide it by 1 every time. So it's 14.6. We're going to multiply it by 7. We're going to multiply it by 24, by 60, and then by 60. Oh, come on. And you get a really big number. So your calculator will put out 8,830,080. Is this correct? Yeah, we've got to refine it a little bit. This would be a number I'd probably want you to write in scientific notation, and we need to round it accordingly. So we'll go with our given piece of information. This thing here has 3 sig figs. Okay, so I'm going to round it first. If it's 3 sig figs, that means that the 8 is significant, this 8 is significant, and the 3 is significant. Everything else is junk information. It doesn't, we're not that precise because our given information wasn't that precise. So if I round it first, it'll be 8, 8, 3, 0, and then I'm going to put zeros in the remaining spots, or it's going to be 8,830,000 seconds. Scientific notation, taking this one step further because this is kind of a large number. My decimal lives here. I want it to live here. So 8.83, and how many hops? 1, 2, 3, 4, 5, 6 times 10 to the 6, and we keep the 6 positive because this is a large number. Give it a unit, seconds. So 8.83 times 10 to the 6 seconds. Any questions on that, on dimensional analysis outside of, we will definitely do a little bit more practice on Thursday, but I want to know if conceptually something in there is not making sense. Okay, I would say most of the general chemistry part of this class is really just glorified dimensional analysis. It's this. So if you can understand the basis of this, it's going to help you through the rest of the first half of the class. Stoichiometry is pretty much just conversion factors. It's just going from one thing to another thing, making sure units cancel. Any questions, comments? No? Okay, so we are going to stop there for today. We'll get some more practice in on Thursday. If you have any questions, stay around and we can talk one-on-one. If you have any questions about dimensional analysis, also feel free to stay around and I'll throw you guys in a waiting room and just pull you in one at a time. Otherwise, enjoy the rest of your day. Feel free to email me if you have any questions, all right? I'll see you guys on Thursday. Bye.